The concept of the sea ice windmill is actually very simple. What we're doing is we're going to pump water from below the ice up on top of the ice. And by doing that, it allows the water to freeze faster, a lot faster. And that's because the ice itself, as it forms, becomes an insulating layer that prevents the cold air of the Arctic to freeze the ice. So, under natural conditions, the ice will only grow to maybe 1 to 3 meters thick. Whereas, with our technology that uses the sea ice windmill, we should be able to pump water from below the ice up on top of the ice and grow the ice at least 3 times thicker. At least that's our goal, so that we can make ice that's thick enough to make it through the summer and last year round. So first, let's consider where we're doing it. We want to choose a place in the Arctic where the ice freezes early and melts late, because that's the area that is most affected by this change. That's the area where we're losing ice. Now, right now in our project, we're looking at the north coast of Alaska near Prudhoe Bay. Now, in that area of coastline, typically the ice is supposed to only melt for about 2 months out of the year, giving 10 months of freezing conditions where you can grow ice. Now, with global warming, that time is now grown longer, and it depends on which year it is, but it could be 3 or 4 months. And that's part of the urgency, is that we need to hurry up and do this before all the ice is gone, before it doesn't freeze back at all. Because once you're in an environment where the sea ice doesn't form, then this technology cannot work. Okay, so think about the sea ice windmill now. We've got a sheet of ice, and we put a hole in the ice, and we put a pump in the hole, and then we start pumping ice out on top, so it freezes faster. Well, anyone who lives in the northern areas where you get freezing conditions, they know that if you just leave your garden hose on at night when it's scheduled to freeze, in the morning you'll have a big giant mess. The ice is going to form wherever it forms and eventually freeze up your hose, and it just won't work. So with the sea ice windmill, we've developed a technology where it grows in a very controlled fashion. And the way we do that is that we're going to shape the surface of the ice to be more like an irrigated field. Now, think about this in concept. Think about a cornfield or a rice field or any kind of large grain field. When the farmer has to water that field, he usually sets up a water pump, floods the field, and then lets the water run in for a pre-described amount of time, and that's what he uses to grow his crops. In very much the same way, the sea ice windmill will work like that. On the surface of the ice, we'll make channels. We'll pump the water out, it'll run down those channels and then spill out over to the flat part of the ice. And then we'll turn the pump off of that section and turn it on to another section. So while that section is freezing, we're pumping water out onto another section. Just like a farmer would water one part of his field and then turn that off and then water another part of the field. Now, by doing that, we will grow the ice very uniformly in the entire region that around the water pump where it can reach. So the amount of ice that we form will depend on the amount of water that we can bring up through the water pump, which will depend on the amount of energy we have available to pump that water. With this technology then, our goal then is to grow these enormous flat blocks of ice that stretch out for many, many meters around the water pump through irrigation style channels that are cut into the top of the ice. And you might think, well, maybe it's going to melt through and crack or something, and we've taken a lot of those considerations into account, and we think we have ways to solve them. I'm not going to go into them here, but that's a topic that we really, really need to get up there and try it and see if these ideas will work. You see, because there's no other way to test these theories about whether or not we can actually form this ice until we get up there and try it. That's why we need the crowdsourced funding, because we need the money to be able to go up there and try it and prove that it works and find out what other problems we'll have that are in the way. For example, in the Arctic is one of the most harsh environments that there is on the planet. It gets extremely cold, it's completely dark during the winter, and there's very, very strong winds. And not only that, the ice actually is shifting around and moving because it's sitting out on top of an ocean. Now, all of these present very, very practical, almost seemingly impossible challenges, but we won't know until we try. Once we form these large blocks of ice, then we've accomplished, in essence, our first goal, which is to make ice that reflects the sun when, with global warming, there would be water and it would cause this runaway global warming effect. But that really doesn't solve climate change. All that does is postpone the inevitable, because the way it's going, the CO2 blanket that is on the Earth is just going to keep making the Earth warmer no matter what. So eventually, even if you do make the ice thicker, and even if you did make it last through the summer, it would only hold off the inevitable for a few more years, until the atmosphere is so warm that the ice just can't form and the water is too warm and it can't form. What we really need is a more fundamental solution to the CO2 problem, and that just turns out that the SIW can bring that, and here's how. If we look at the world today and we think of the amount of CO2 that man is pumping into the air, it's an amount that's equal to about 35 billion tons, that's B, billion tons of CO2 every year. Now, no matter what you do, if you invented a machine, for example, that sucked the CO2 out of the air, that machine would have to have the capacity of every single fossil fuel burning engine on Earth just to stay even, just to keep the CO2 from rising further. Imagine as many CO2 engines, removing engines, as there are car engines. Clearly that doesn't make sense. So what we need is we need to use Mother Nature to help us take the CO2 out of the atmosphere. Now typically you hear about that by, let's plant more trees. And obviously that makes sense. Trees are composed of CO2 that comes from the atmosphere. Now, with the sea ice windmill, we can grow photosynthetic microorganisms. That's one of the coincidental features of this technology, is that it happens to create what we think is an ideal environment to grow photosynthetic microorganisms. Now, how do photosynthetic microorganisms solve climate change? Well, here's how. A photosynthetic organism is composed of CO2 from the atmosphere and nitrogen from the atmosphere. That's all it takes for these things to grow. These single-celled organisms are some of the most ancient life forms on Earth. They've been here for some 3 billion years, and they form the base of the food chain. Now, these organisms already exist in nature. They exist in abundance in nature. However, if they grow in an environment where there's other organisms that eat them readily, then their populations will go down, and they will not be able to achieve the quantity that's necessary to actually impact the removal of CO2 from the atmosphere. That's all different with the SIW technology. We're talking about growing giant flat ice sheets with flowing water on the surface. It is an ideal environment for growing photosynthetic organisms. And there are no other predators. There is no other bacteria, there's no other zooplankton there, because it's out on top of an ice sheet. It's in an environment where the photosynthetic organisms are, that's where they grow and nothing else grows. That's why this will work.